Hello, this is Ugo Bardi. I will be speaking to you in this clip about this recent report to the Club of Rome that we published this year. It's the title says what it is about, but to tell you a little more, it is part of a series of studies that the Club of Rome produced during the past 50 years or so. The first one was this one, The Limits to Grow, of which you see the main result printed on my t-shirt. This series of reports were the first attempt to understand, by some models, the trajectory of humankind embedded in the ecosystem that supports our life. And the results are known. They saw the possibility of a crash because of overshooting, because of overexploiting the resources that we have on a finite planet, and also because of pollution, and one problem also was overpopulation. So the problem of population is very important. It is very basic. It's a feature of the story, which has a very strong emotional and political appeal. If you discuss these matters, you see it immediately. People don't deal with this thing just a question of numbers, of overshooting, of trajectories, of exploitation, of economics, of something like crude oil or natural gas or whatever. This is population. Population is us. And so we are emotionally connected to the subject. We have to discuss it. And it is not easy. It is not very easy. I noticed that in all the presentations I give on this subject. So this one is a web presentation. Let's see what you think about that. In any case, let's see. In general, we have a double view, two different views of the problem. Some people, as you surely know, are worried about overpopulation. We are too many on this planet. We are doing damage to the ecosystem, and eventually this damage will go back to hurt us ourselves. Or the other section of the population, the fraction of people who discuss this matter, say, no, this is not a problem. Population is stabilizing. We may have the opposite problem, the problem that we don't have sufficient fertility to replace the natural decline of population, with the old people naturally marching away from this planet into another planet, or Elysian fields, or whatever you think you go when you're finished your trajectory here. And this report is a little bit out of this discussion, in the sense that as many things that the Club of Rome produced, this one goes a little bit against the conventional wisdom. Because right now, the conventional wisdom is mostly that the problem is overpopulation. But we say, well, it is, but be careful, it is not so simple. And also another point in which the report goes against the conventional way of presenting the problem is that the low fertility of women today is normally attributed to socio-economical factors. Women don't have enough children because they choose not to. And here we are saying that, yes, it is true, it is a problem, but there is another problem, quite possibly just as important, perhaps even more, in the fact that we have a big problem of pollution that's affecting human reproductive system, both men and women. It's a very serious problem, you see, but these matters have to be discussed, and it takes a whole book, you see, not a very small book, difficult to understand. You have to put some work on it, and I hope that if you have time to read this, you will understand a lot of things, but in this clip I'll try to summarize the situation. So, where is that we stand? As I said, there are two views. Let's start with the question of overpopulation. Why do we say that we have an overpopulation problem? What is wrong? How can we quantify this? How can we decide what would be a good number and the wrong number, too big or too small. Let's see. Usually at this point, I show a slide here, which is the following slide. And you can see, you see, at least in this place, at that time, this is Bangladesh, some place where there is a festival, some kind of a religious festival, where a lot of people are attending. And looking at these scenes, you surely have the impression that, well, no, let's not say overpopulation, let's say crowding. There's some crowding here, but is it real a problem of overpopulation? Can we say that we have an overpopulation problem from a single place, a single moment, and a single video clip? We need to be much more quantitative. And nevertheless, people have this idea that we do have this problem. We do have this problem, and you see the blue thing here is a measurement made using Google Ngrams, which tells you how many times the term overpopulation has been mentioned, printed in some book over time. You see, from the early 20th century to now. You see, there has been this big peak of interest in overpopulation. Was in the 1970s, where people started being seriously worried, saying, what are we doing here? We are 3 billion at the time, they were, and we're growing exponentially. And so if we keep growing exponentially, what the hell is going to happen? The planet will explode, the people will start eating each other or whatever. And then the thing sort of died out for various reasons. One was that these peaks tend to go up and down by themselves. It is when some subject is over discussed, then it sort of tends to go down in interest. But we keep discussing. So you see, we are still discussing the problem of overpopulation today because really it is a problem. We cannot deny it, but we have a lot of people. But what does it mean exactly? What is too many? We don't really know. We need some quantitative data. And so this is quantitative here, as you can see. This is impressive in the sense that you see that human population has been well below 1 billion, around 500 million individuals up to the mid 18th century, and at some point it started growing up, and that not just exponentially. Exponentially is already fast enough, but if you analyze these curves, as Professor Yakovienko did recently, you see that it's not just exponential, it's faster than exponential. And as a fundamental point, you see that this fantastic growth started with the start of the exploitation of fossil fuels. The mid-19th century here is the point, more or less, when the use of fossil fuel called coal, started being important. At that point, we had a source of energy which allowed us to grow, and reach today more than 8 billion people. But again, this is impressive, but we have to be, again, some more quantitative, because, okay, a lot of people, never seen so many people on Earth. Is it a problem? Why is 8 billion a problem and not, say, 80 billion or maybe 800 billion people? What would happen? 800 billion people would be a little bit worrisome, might say, but if you think about that, in the Middle Ages, telling people that we would grow to such level, they would have looked at us as, how is it possible? There cannot be 8 billion people on Earth, so maybe we could have 80 billion or not. Is a question of impact on the ecosystem, because humans are not self-sufficient in themselves. They need a working ecosystem to have food, to have air, to have water, to have all the kinds of minerals and proteins and sugar and everything we need to survive is produced by ecosystem. We cannot yet produce food from fossil fuels, not directly at least, although it is what we are doing indirectly in terms of fertilizers, but we need a working ecosystem here. And the question is, what is the impact of the humans of this system? And that, I think, it start being a little bit worrisome, truly worrisome. This is something that when people see it, they are worried, because it is starting to be known, but it is not so well known as it should be. And notice that the light blue here are the wild mammals, the percentage in terms of mass of wild mammals, elephant, whales, whatever, wolves, and whatever kind of mammals you can think of. The rest, 96%, is either humans, 34%, or domesticated animals, livestock, cows, pigs, buffalo, whatever. Well, this is worrisome, I'd say, because it has something in natural. What's happening? How is it possible that humans have appropriated 96% of the mammal sphere inside the ecosphere? We cannot prove that it is something bad, but it sounds and looks bad, I think, because, as I said, we need a working biosphere, a working ecosystem, and for a biosphere and an ecosystem to work, you need to have a certain diversity. It is not a question of aesthetics, it is a question of survival. We need these things, and we are unbalancing the whole thing toward an excess of human appropriation of the resources that the biosphere can produce. And that's not just for mammals. You would say, well, mammals just a fraction of the biosphere, true, but let's move to another in the image. This is a little bit old, but it still tells you the same thing. This is the vertebrate biomass. So it includes not only mammals, but birds, reptiles, amphibians, or whatever. And that's even more worrisome because the trend is the same. And as you see, the mass of the non-human part of the biosphere remains a very, very tiny fraction. And this image shows you another thing that you may have not been able to deduct from the previous figure, that the global carrying capacity, that is the capability of the biosphere to produce biomass, because called also with other names, depends exactly how you measure it, is also called primary productivity. And humans are appropriating so much that they are causing the global productivity to decline. You see it. And that's the problem that I was telling you. Humans are not only appropriating resources for themselves, but for everything. It is declining. The whole biosphere is suffering for the weight of human beings, and that's one of the factors. This is one of the measurements you can quantitatively make in order to understand the impact of humans on the system. But you can make more than that. You can go see, for instance, if there is a relationship between CO2 production and human population. And you see, this is a recent results, but it was already known. There is a very clear correlation between the number of people here on the y-axis and the CO2 level on the x-axis. This is not just correlation, this is causation. We know this. We know that CO2 is increasing because people are burning fossil fuels, and this goes unreasonably linearly with the growth of population, although maybe an extrapolation tells us that things might change, but still the damage has been done. You know that CO2 is causing warming, and the recent data show that this is not the only problem about CO2. And I know also that but most people at this point seem to have concluded that CO2 is a harmless, poor molecule which has been defamed by a group of evil scientists, but I invite you to consider that there may be something right in the idea that CO2 is not just food for plants, and you're not a plant, but something that's doing us damage and will do us a lot of damage. And you see how the temperature goes up with the number of people on Earth. So we are directly causing, or at least generating this increase in temperature. And that's one of the two problems. I told you this is the sort of the main view in the debate. I'd say that perhaps a larger fraction of the people who discuss this matter think that we have an overpopulation problem, but the other side is not so small. It is just as vocal as the first fraction, and they have a completely different view. It's normal. We humans have problems in understanding complex problems. We tend to simplify what is the problem. One thing, and it is in politics, there is one problem, one solution. It is never like this, but we tend to think in this way. So some people say, no, the problem is not overpopulation, but depopulation. I see what's happening. And that's also something that starts being known, but most people don't know about this. The fact that back in the 1950s, starting with 1950, the fertility, here you measure it, total fertility rate, which is the number of children per woman, went down, wow, like this. And, in order to ensure the continuation of the species, women have to have at least 2.1 more or less children. Every woman should have, on the average, 2.1 children. And we are very close to the replace limit, and we are going down. We are about 2.2, 2.3, and you see it is distributed in this way. The red points are the industrialized rich countries, which are all below the replacement limit. The poor countries are still above the replacement limit, yet they are all following the same trajectory. They're all going down in fertility. We are having what is called the demographic transition. Demographic transition means that the population is going to stabilize or decline because of a reduction in fertility. Not the same thing that Malthus, good old Malthus, had said a long time ago. He said our population is going to stabilize because of wars and famines and plagues and whatever bad, the 4 nights of the apocalypse or whatever. No, we are, fortunately, I'd say, stabilizing the population, maybe stabilizing the population by means of this decline in fertility, which is in itself not a bad thing. Women were still having 5-6 children per each one, and then we'll still be growing like that, and then we would really have hit very serious problems of resources, of availability of food, fuel, energy, air, and water, which we still do. So this idea, this datum that we have, led some people to say that we need more babies, which is another line of thought. So this is another measurements of the number of times that the terms population collapse have been printed in books over the past 50 years or 70 years or so. And the problem is there. Elon Musk is one of the most prominent vocal of those who say, well, the problem of low fertility is more important than the problem of overpopulation. Is it true? It's not completely wrong and not completely true. Depends. As I said, there are no simple definitions that can define a highly complex situation such as the human population embedded within all the other parameters, which are the pollution, resource availability, atmospheric composition, very complicated. But just as a note here, why is that? Well, we know that populations tend to follow certain trajectories. It was known from the time of Odum, one of the great ecologists of the past, and we know that all population tends to stabilize. That's typical. But in the biological world, biological resources are normally renewable. So this is the diagram that applies to a situation in which a population grows, exploits a resource, food, and then gradually stabilize its population at a level compatible to the availability of food. Is what you expect to happen, and many times it happens. How it is done, there is a variety of mechanisms. The interesting thing is that you could redo the calculations by Odum for a non-renewable resource, and this is our case because, as I showed you before, the growth of the human population is directly related to the use of fossil fuels, and the use of fossil fuels is what gives us food, because without fossil fuels for fertilizers, mechanization, transportation, refrigeration, packing, all the rest, we would not have by no means enough food to keep 8 billion people alive. And if you do this calculation, you see that you have this shape, which is what I call the Seneca curve. You see it here. This is the Seneca curve. It's from a phrase by the Roman philosopher Seneca, who said, well, you see, the things tend to grow slowly and then to go to ruin fast. And this can be quantified. This is something basically known. And this is what we see as a characteristic of ecosystems, including human one, let's say, which is us, which is what we do. And an interesting point here is why people do this. We have this possibility. Why is that happening? Because humans theoretically are not like biological creatures who don't reason, don't plan, and yet I think we are following the same path. This Seneca curve, which started long ago with our ancestors collecting around a fire, then going through various stages of civilization, and then bang, maybe we could be going towards collapse, a true collapse. Why this? Well, it's an interesting story. As I told you already, there are two main ideas here. As here, one mainstream idea and one subversive idea. The mainstream idea is that people don't want children, women, but people in general, families, because socio-economic factors. We think we don't have enough money to raise so many children, we don't have time, I have other objectives, career, and making money and things, and there is no space left for children. Actually, it's interesting now that if you ask people, why don't you want children? Well, they said, let's say, well, because we don't want them. There is no logical explanation, but people just don't want them, or maybe they want, but they found that they cannot have them because there is another big problem, which has to do with the pollution problem. And you see the work of Dr. Swan. She went to look at this question in depth, and she found that one of the problems is the decline the number of sperm cells for human males. So we have sperm cells are going down, and that affects fertility, but not just that. Testosterone is, as you know, a sexual hormone that affects men. It is going down too, and then there are many other entities which may affect the human reproductive system, which is not just biology, but in large part it is biology. It is microplastics and the estrogens and whatever, and also cultural messaging, that make you lose time in other things than reproducing. Some people say this is even porn, although there is no proof that it is the case. Anyway, it is what we're seeing. It is what we're seeing, a big decline in fertility, which causes not yet, because population has a certain inertia, but it is reducing the number of young people who can reproduce. And so as the older people march toward the Elysian fields, we are going to see a decline in population. It is unavoidable. We are already seeing it in a lot of countries in the world. All the industrial countries are declining. They are partly counteracting this by means of immigration, which creates a lot of more problems, which let's not discuss that here because it's a big problem. And I'd say now that it's a fortune. We are lucky that this is happening. This is an opportunity, because if we are in overshoot, if you are overexploiting the ecosystem, then it is good that population is stabilizing and probably declining in the future. And we don't need for that to have the 4 nights of the apocalypse to gallop towards us. Right now, we don't see the problems that Malthus and others had thought would be the most important one, like famines and wars and pestilences and the pandemics and whatever. Not yet now, because it is not at all obvious that they won't appear, hopefully not, in the future. So, just to tell you that we are not discussing theoretical things, let me show you some examples of the collapses, population collapses, which did occur in the past. As for instance, this one, the ancient Rome. That's an old story, and these numbers here are very approximate. There is a lot of uncertainty, but the whole basic story is true. Rome grew exponential up until about 200 of our current era, and then it collapsed. And why did it? For a combination of things. As always, for complex systems, there are combinations. There is rarely a single pushing thing that moving a system to collapse. In this case, it was in part resource depletion. The Romans were a mineral-based society. In part, it was because of pollution. The Romans had a big pollution problem, because with the metals they smelted, they were in part at least poisoning themselves. This is an old story, but I think it's still very important for us to consider and to learn from it. But it is by no means the only one. Let me show you a very recent one at Ukraine. And that's one of the many cases. Don't think that Ukraine is anything special. It is just more, it's clearer. We see the big change. So up to 1991, when the Soviet Union collapsed, Ukraine was a reasonably prosperous country whose population was growing and reached the maximum, and then nobody expected the Soviet Union to collapse. But with the collapse, we had this decline, this fast decline. You see, it's again the Seneca shape. Collapse is faster than growth. Why that? Oh, for a series of reasons. Collapse of the social security, poorer food. Nobody really starved, but the diet became poorer, and the economic problem and stress and emigration. Also, people left Ukraine, and also fertility also went down. Women tended to postpone birth, and that you see for about 10 years, or might I say 20 years, it went down like this, and then you had another hammer hit on the poor Ukrainian people, the war, which led to more of the same, in this case dominated by immigration. And then this is to see how bad population decline can be. It is heavy. And this is a modern problem, but we have other cases in history, like about the Irish population. The Irish population, as you know, in 1845, we had this huge collapse with the famine, of the Great Famine of 1845, which killed off about half of the Irish population at that time, about 8 million, which went down gradually to 4 million in a few decades. And that was not just because of starvation, for a series of correlating disaster when you have people not eating enough, they are sensitive to infections. Then there's many migrated, and then so many decided not to have children, and so that's at least it is to show you that these things happen. Now, whether can it happen to the global population, I'd say it can. It is possible. It is happening in history. So why we should discount this possibility? We have to be careful, because a decline like this is not a gentle decline that removes the problem of exploitation and things like that. It is a disaster. And so what is going to happen? I think I can show you a few predictions. Maybe these are predictions, but predictions are very difficult. No one has a crystal ball in his hands, so predicting what's going to happen is probably impossible, but we can at least try to understand what's going on, and what's the way we try to project what we think into the future is to use models. Models are reflections of what we think. They are quantification of our ideas. They are no crystal balls. They are system, that may help us think about what the future could be, not about what the future will be. That would make no sense. So, for instance, you see at the top left the calculation by the demographic models by the United Nations. Here you see that the models predict a slow stabilization of the population, which will gently reach 10 billion about 2008, and then start declining. But it is not to say that the people who make this model incompetent or they're doing anything wrong. Absolutely not. The model has some rules, some ideas, some basic inputs, and it will operate according to what you put into it. So these kind of models, purely demographic models, contain no data about such things as pollution, global warming, wars, or big problem of immigration, or something about immigration. So if you don't consider the effects of, say, pollution, you won't see them in the final results. So this model, I think, are a little optimistic in the sense that they do not predict any kind of collapse. But as I showed you, as I am showing you this t-shirt, already in 1972, the Club of Rome was proposing a model that, let me repeat, was not a prediction, that saw the possibility of a population collapse mid 21st century, around 2050, 2060. Then, of course, that was more than 50 years ago, and needed to be redone and readapted according to the data we have now. And you see, this one here by Nebel and others is probably the most recent study, still made using the same, not the same, but a similar model. And in this case, the population peak has been shifted much closer to our present. It may happen during this decade, according to this calculation. And be careful, this is not a crystal ball, it is not a prophecy of doom. It says, given some conditions, it could happen. The population indeed is going to stabilizing, and it might decline in the near future. There are other models which tell you similar things. I'm not going into the detail here. There are many more than these 5, of course, just to let you know that there is a huge number of models, most of which, those who take into account all the contour, the things that that can affect populations, it assume that we will have decline, which could be very rapid, Seneca style, in the coming years or at most decades. And that's something that we should worry about, or at least consider, because as I said at the beginning, a population decline is not a problem. It may be an opportunity. It is a good thing if it reduces our impact on the ecosystem. But if it is too fast, it might wipe out that entity that we call civilization. And this needs to be considered, as you can imagine. So let me try to conclude. Here is, as I said, is a highly complex situation, but we may try to summarize it in just 3 points. And first is that we are in overshoot in the sense that the ecosystem, Earth's ecosystem, is unable to feed for a long time such a huge number of human beings. So at some point in the future, a population decline is absolutely unavoidable. So what do we have to do? Well, recognize that this is not a bad thing, because we need to decline, to reduce the numbers. So we need to do this in some way that is not violent, doesn't force people to do things they don't want to do. They don't want, we don't want to use violent means to obtain this. It is coming by itself, which is good, but we need to manage it, because if the decline is too fast, then it will take the aspect of a collapse, and that would be clearly a bad thing for us. For your knowledge, quickly let me show you this site that it is related to the book that we published. It is not a book, it is a summary of the book, but it is an interactive system which will answer your questions about population with the voice of Ugo Bardi, my voice, and it will be it is not just a summary. It is, you can ask questions, you get answers, you can ask inconvenient questions. The answers may not be so nice. It depends. This model is trained to answer with my voice and sometimes with humor, and see whatever. It's not a substitute to reading the book, but if you're curious about some specific facets of the book, then by means of this site you can get some answer that may help you, may give you a better idea of what we're discussing, and hopefully make you more willing to read the whole book, which, as I said, it's needs some work, there's no doubt about that. So this is the final slides, and as I said, nobody has a crystal ball. We try to do our best. Actually, if I think about that, I do have a crystal ball. But this is for fun, mainly for fun, but I keep it on my desk to remind myself that predict the future is very difficult, and we have to be careful about what we do, what we think, and how we manage the humankind's commons. And thank you very much for listening.